Substances that we use in our daily life can be classified as acids, bases, and neutral substances. Acids. The word acid is derived from the Latin word acere, meaning sour. So, acids generally taste sour. On the basis of the source, acids are classified as 1. Organic acids. 2. Mineral acids. Organic acids occur naturally in animal and plant materials. Examples: sourceate tartaric acid, grapes acetic acid, vinegar, and tomato formic acid, stings of ants and bees. Malic acid, apple citric acid, lemon and orange lactic acid, milk. Mineral acids: hydrochloric acid, HCl, sulfuric acid, H2SO4, nitric acid, NO3, etc. Are some examples of mineral acids that are used in the laboratory. Did you know the fact that when we exercise a lot, lactic acid gets accumulated in our muscles, which leads to cramps? Acid rains: pollutants such as sulfur dioxide gas and oxides of nitrogen present in the air react in the atmosphere with water and oxygen to form sulfuric acid and nitric acid respectively. These acids come down as rain. Acid rains cause great damage to plants and animal life. It also damages buildings and monuments. Acids can be strong or weak. A strong acid is highly corrosive and can cause severe burns. Nitric acid and sulfuric acids are a few examples of strong acids. Weak acids, on the other hand, are not as destructive as strong acids. Organic acids are generally weak acids. Bases. Basic substances are those which contain bases. Example: sodium hydroxide, no calcium hydroxide, CaO2. Bases also occur in plant and animal bodies such as cornstarch, fresh egg white, etc. Many bases are found in household cleaners. Bases may have a strong irritating odor and should be used with caution as it can harm the skin and eyes. Like acids, bases can also be strong or weak. Strong bases are very corrosive and can burn the skin. Caustic soda or sodium hydroxide, NO, and caustic potash or potassium hydroxide, CO, are strong and corrosive bases. On the other hand, copper hydroxide, CuO2, zinc hydroxide, ZnO2, and ammonium hydroxide, NH4O, are weak bases. Did you know that our stomach contains hydrochloric acid, which helps in the digestion of food? The acid does not harm the stomach because the walls of a stomach are protected by a mucus lining. To overcome this, certain chemicals called indicators have been developed. Indicators are substances which show a change in color when brought in contact with acids and bases. Natural indicators. Turmeric powder mixed with a little water gives turmeric paste. In a basic solution, this indicator changes into red, while in acidic and neutral solution, its color does not change. Litmus is a natural dye extracted from lichens. It is purple or mauve in color. It is available either in the form of solutions or in the form of strips of paper known as litmus paper. Litmus paper is either red or blue in color. It changes color depending upon whether the compound is an acid or a base. Blue litmus paper turns red under acidic conditions. Red litmus paper turns blue under basic conditions. There are many more natural indicators used, like China rose, etc. Synthetic indicators. Phenolphthalein is another indicator. Acids turn colorless and bases turn pink in phenolphthalein. Methyl orange is another indicator. Acids turn pink and bases turn yellow in methyl orange. Scientists have made it very easy to know the strength of an acid or a base. Different strengths have been given what is known as a pH number, which ranges from 1 to 14. 1 is considered as strongly acidic and 14 strongly basic. 7 is neutral. You can measure pH of a solution using universal indicator. Salts is a general term used for the substances that are formed when an acid and a base react with each other. This reaction is called a neutralization reaction. The reaction between vinegar and baking soda is also a neutralization reaction. The common table salt is formed by the reaction of hydrochloric acid, HCl, with sodium hydroxide, NO. Hydrochloric plus sodium hydroxide, sodium chloride, salt plus water, acid plus base, salt plus water plus heat. Salts can be acidic, basic, or neutral. Neutralization in everyday life. In digestion. To digest food properly, the liquid in the stomach must be acidic. But too much acidity leads to indigestion. 1 takes antacids, which usually contains baking soda or magnesium hydroxide, to neutralize the excess acid. Insect stings. When a bee stings, it injects an acidic liquid into the skin. The sting is neutralized by rubbing calamine lotion, which contains zinc carbonate. Soil treatment. Most plants grow best in neutral soil. If the soil is too acidic or too alkaline, the plants do not grow properly or do not grow at all. Usually, it is too acidic, so a base such as quicklime, calcium oxide, slaked lime, calcium hydroxide, or chalk, calcium carbonate, is added. Factory waste. Liquid waste from factories often contains acid. If it reaches a river, the acid will kill aquatic life. This is usually prevented by neutralizing the waste by adding a base such as slaked lime. Did you know that our skin is weakly acidic? Hence, we should be careful in selecting soaps and shampoos as they are basic. Enough for today's video. We will be back tomorrow with more informative video.